Hey guys, today we are going to be talking about the Earth layers. Some questions we are going to address are what are the main characteristics of the Earth's layers and how can Earth's layers be illustrated? Here we've got a diagram of the Earth's layers. We have the inner core, and it says here the temperature, it's about 4,300 degrees Celsius, and it is solid iron. The outer core, here's this yellow layer, it is liquid iron, sulfur, nickel, and it is about 3,700 degrees Celsius. The mantle is this orange layer, and it's made of magnesium, iron, aluminum, silicon, oxygen, and runs about 1,000 degrees Celsius. The crust is the coolest layer, and it's also the thinnest layer. It's very rocky, and we're going to start talking about the crust first. So, it's the outer layer of the Earth. It's the part of the Earth we are most familiar with. It's the thinnest layer, and it is made up of two different types of crust. So we have continental crust here, which makes up the land. And then we also have oceanic crust, which is the crust that's beneath oceans. It's a lot thinner, it's a lot denser. So under the ocean is oceanic crust, and the land is called continental crust. It ranges from about 5 kilometers to 50 kilometers thick. You can see the oceanic crust is a lot thinner than the continental crust. So typically the thinner range, the lower range is referring to oceanic crust, and the higher end of the range is continental crust. We have making up the crust and the top of the mantle. It's broken up into a few different layers. We've got the lithosphere, which is the crust and the upper part of the mantle. So that would be like this brown and grayish area. And then we have the asthenosphere, which is liquid, and the lithosphere kind of floats on top of the asthenosphere. And you can see that it kind of ranges in thickness. And then the lithosphere, asthenosphere, and the rest of the mantle are all considered one layer. But when we talk about plates moving and land moving, that's because of the lithosphere and the asthenosphere. Then we have the the outer core and the inner core. So here we've got our Earth and that oceanic crust where there's lots of ocean. A thin layer of it's a thin layer of the crust that lies at the bottom of the ocean or is underneath the ocean. It's more dense than continental crust. Remember, density is how much stuff is in an object, how much stuff compared to the space. So there's a lot of crust, but it's smushed down, so it's a lot more dense. It's mostly made of basalt rock, and it's thinner than the continental crust. Remember that, 5 to 10 kilometers. It's a lot newer than continental crust, and we'll talk about that in a few minutes. So here we've got our continental crust. It's a layer of rocks that form the continents. So continental continents. It's less dense, so it's less compact, less squished down. It's mostly granite, and it's thicker than the oceanic crust, and it's older than the oceanic crust. We will skip this slide for now. So I'd mentioned the lithosphere earlier. The lithosphere right here is the thin layer that the crust, oceanic and continental crust, lie on top of. It is the solid outer section of the Earth, and it includes the crust and the top layer of the mantle. And then we've got the asthenosphere that's under that. It is the solid part of the upper mantle. It's less rigid, which means it's kind of like silly putty, where it's plasticky. It can stretch, but it's very flexible. The crust moves over the asthenosphere, and the plates crash into each other. So here we've got a picture. We've got the lithosphere, which involves the continental crust in the top part of the mantle, the asthenosphere. Oceanic crust is this thin one right here, the dark gray, and continental crust is the dark gray right here. Next we have the mantle. This is the largest layer of the Earth, and it starts right under the crust and goes about 2,890 kilometers deep. So it's very thick. The super intense heat from the core causes the rocks in the mantle to rise, and as they get away from the core, they start to cool, and that makes them sink again. We call this movement convection currents. So we've got our outer core, it's almost like a heat source, and as it gets hotter, they rise up, but our crust is cold, so our crust cools down these rocks to get to the top, and when it cools, it starts to sink again. And so we have this circular movement called convection currents, and this causes the crust to move. The average temperature in the mantle is about 3,000 degrees Celsius, but it changes a little bit depending on how deep you go. Next, we've got the outer core, which is this yellow layer right here. It's a liquid layer. It's about 2,300 kilometers thick, so it's almost as big as the mantle, but not quite, so it's the second largest. It's mainly made of liquid iron and nickel. So those metals are, they're very high melting points, and so it's very, very hot, and that makes them liquid. It lies in between the inner core and the mantle, and the average temperature is about 4,000 to 5,000 degrees Celsius. So like I said, very, very hot. The inner core, however, is a solid ball of metal, and that's because there's so much pressure pushing on the inner core that it can't turn into a liquid. There's not enough space for it to turn into a liquid. It's about 1,250 kilometers thick. It's nickel and iron, similar to the outer core, except that it's solid. It's hot that it melts everything in the outer core. So this is almost like the heat source for the outer core. It's so hot that it keeps the outer core melted. The inner core is the densest layer of the Earth. The average temperature is about 5,000 to 6,000 degrees Celsius. So it's hotter than the outer core, but because there's so much pressure, it forces it into a solid state. And again, the pressure and the density, or the pressure on it, keeping it a solid makes it the densest layer of the Earth. So why do we have layers within our Earth? We have layers because the different materials that make up our Earth have different densities. The more dense materials move toward the center of the Earth, while the less dense materials move toward the surface. So each layer is increasingly more dense. And how do we know about the inside of the Earth? We study seismic waves, which are like earthquake waves, to infer about the Earth's interior. Seismic waves travel differently through different layers, slowing down and speeding up and stopping completely. So when a seismic wave hits the inner core, it behaves differently than it would through the outer core, the mantle. And so they study how the waves travel through the Earth, and that's how they're able to make these discoveries about what the inside of the Earth is like. After we've gone through all these notes, you are going to complete this assignment on Schoology. It's called Earth Layers Diagram. You are just going to label the 4 layers of the Earth, and then you're going to add 2 descriptions for each layer. So I've included the notes in Schoology, so you are welcome to use the notes to help you pair up the labels and the descriptions, put them next to the arrows. You will have 2 descriptions for each layer. Let me know if you have any questions.